All right, boys and girls, welcome back to the drive-thru for a special live taping edition. Okay. I thought we could get a little more hype than that. As always, this live rendition of the drive-thru is brought to you by the deli. Hungry? Stop by the deli. Make yourself an old-fashioned ham sandwich melt with ham Swiss on a white bread. All right, so we've got new vocabulary to start. So the median of a triangle, there's 3 medians in every triangle. Okay, so if we have triangle AB here, okay, the median of the triangle goes from a vertex to the midpoint of the other side. So there's one median. Okay, I'll draw one more. Keep in mind, there are 3, but I'm just not drawing them all. There's another median. Okay, that's what a median is. A median bisects the opposite side from the vertex. Okay, an altitude is something you're familiar with and is referred to a lot of times in younger geometry classes as a height. Okay, so here if we have triangle max, an altitude starts at a vertex and is perpendicular to the opposite side. Okay. Now, a segment can be the altitude itself. So here, in this example, mx is both the side of the triangle and an altitude. And you might even remember, because you're so darn smart, that an altitude does not have to be inside of the triangle. So here, if I wanted to draw the line that's perpendicular from that point to the opposite side, I would have to draw it outside the triangle, and that would be the altitude. Okay, so those are some key pieces of vocabulary that are now going to show up in our proofs as definitions. So you'll need to know the definition of the median and the definition of the altitude, because you're going to use them in proofs. You'll see that coming forward. All right. So, a new postulate. Just something else that you're going to use in proofs. 2 points determine a line. What that means is through any 2 points on Earth, you can draw a line through it, or a ray through it, or a segment through them. I should be saying them. Okay? And you're going to have to draw some auxiliary lines in proofs. Auxiliary lines. What that means is that's a line that doesn't currently exist. So if you did number 20, from the 3-3 homework, you saw a problem where, let's see, how did it work? Where did the other ones come from? I can't remember. Oh, yeah. Okay, I got it. You saw a problem like this. And they wanted you to prove that these 2 angles were equal. Well, the only way you could do that would be to draw some auxiliary lines. Now, with those lines included, you could say that all radii were congruent, and that we could say that those triangles are congruent by side, side, side. So that's the point of drawing auxiliary lines. And again, you'll see that in the next few examples. The rest of this video, we're just going to bust out 2 proofs. One of them is 8 steps. So I hope you're really putting your best focused foot forward when you're doing this work, because some of you are achieving at a great level right now, and some of you are just so close to being there, and if you just keep working at it, I think you're going to start figuring this stuff out once these proofs get a little harder. So, here we go. CD and BE are altitudes. So here's our new word. We're going to have to use that for something. When they tell us that we have altitudes, what are we going to deduce from that? We're going to deduce perpendicular and then get to right angles. And then we're going to say the angles are equal. So now that you can sense why these proofs are going to start taking longer. We're also given that AD is congruent to AE. Now what I'm going to do here, which is a good strategy, is I'm going to just pull a little mini picture aside. Okay? I have a feeling we're going to have to prove that triangle ADC is congruent to triangle AEB. So I just pulled those pictures out because I think it's going to help me in my proof. All right, let's see it. I don't know if I'm going to have enough room to do all this. I'll try to write as small as I can. All right, so CD and BE are altitudes, and AD is congruent to AE. That's given. Okay, so let's mark it on this too. All right, well, we know that angle AEB and angle, hold on one second. Okay, what I was doing was checking to make sure, so this is a new thing that I've just clarified for you guys. Since we know that CD and BE are altitudes, we can say that AEB and ADC are right angles. Okay, if you look in your book, they include kind of two different definitions of altitudes so that we can directly say that they're right angles. So that is the definition of altitude. If a segment goes from the vertex and forms a right angle with the opposite side, then it is an altitude, okay? So now we can say that angle AEB is congruent to angle ADC. And that's because all right angles are congruent to each other. So let's label that. We got this, and we got this. We got this, and we got this. Well, here's where you're just going to have to be creative, smart, and visually, I guess, advanced, because we're trying to prove that those triangles are congruent. Okay? Let's see. I got these drawn a little backwards. If I said this, angle A is congruent to angle A. That would be reflexive. So what I'm saying is this should be an A here, an A here, and then A, E, this should be a B, and this should be a C. Okay, that's better. Now I've got that, and now you can see that I could prove that triangle AEB, order matters, is congruent to triangle ADC. And my reason? What do you think, class? What's my shortcut reason? That's angle, side, angle. Okay? So now, let's see, I'm trying to prove that DB is equal. Ooh, wow, this is tough. Alright, so now what I can say, look, I'm trying to prove that this little piece, which is not part of the triangle that we just proved, is congruent to that piece. Those are not segments from the triangle. So watch what I'm going to have to do here. First, I'm going to say that AB is congruent to AC. AB is congruent to AC. And what allows me to say that? Look, AB congruent to AC. What allows me to say that? CPCTC. Okay? But hold on. You've got two big segments are congruent, and we already know that the little parts of those segments are congruent. So how can we say that DB is congruent to EC? Very good. And our final step will be DB is congruent to EC, and my reason is segments subtraction. It was only 7. I was thinking it was going to be 8. I think the book rewrote the givens twice, okay? All right, one more, auxiliary line proof. Okay, given G is the midpoint of FH, and EF is congruent to EH, okay, so we have EF congruent to EH. All right, well, this is going to be a case where in order to prove that angle 1 is congruent to angle 2, I think we're going to need to prove these congruent first and then use some congruent supplements. And the only reason we're going to be able to prove those congruent is if we prove the triangle's congruent. So let's draw EG. So I will actually say in my proof, draw EG. My reason is 2 points determine a line. So I've now covered that postulate that we learned today. 2 points determine a line. So now I can say that EG is congruent to itself, and that's the reflexive property. Okay. Oh, G is the midpoint. So HG is congruent to FG. By definition, a midpoint. And now we have triangle EGH is congruent to triangle EGF by side, side, side. Okay? So now I know that angle EHG is congruent to angle EFG, and that's CPCTC. And now I'll say angle 1 is sup to EHG, and angle 2 is sup to EFG. Okay, and my reason for that is assumed from diagram. I would also take definition of supplementary there. Alright, so look, I've got angle 1 is supplementary to EHG, angle 2 is supplementary to EFG. So now I can say that angle 1 is congruent to angle 2 by the congruent supplements theorem. And we've just done an 8-step proof. Give it to me.